Okay, so Leetcode practice time. This is the last question for today. There are two goals for this video. The first one is to see how do you solve this problem, and then we are going to put some code in. And the second one is to see how to behave in a real interview given the question. So let's get started. Remember, the first thing is to always try to understand the problem. If there's anything unclear to you, please ask the question to the interviewer. And also think about some edge cases which we need to take special care of in the next step. So let's read through the problem. So it's called design a data structure that follows the constraints of a least recently used cache, which is LRU cache. So implement the LRU cache class. LRU cache. So LRU cache is if you have some capacity, and the least recently used item is going to be removed. So that's essentially what an LRU cache is. So let's say it has a constructor which initializes the capacity of the LRU cache. So it's for sure to be positive, which is in bold font. So it has a get API, and if the key doesn't exist, then it return -1. And it has a put API to update the key and value. So if the key value exists, then we try to update it. Otherwise, we will add a new key value pair into the cache. So if the number of the keys exceeds the capacity from the operation, then we evict the least recently used key. So follow up. So can you do get and put in a one-time complexity? So of course we can. Yeah, so there isn't too much to clarify. I think pretty clear, and also I don't think of any edge case at this moment because we have some pretty strong assumptions saying that the capacity is going to be positive for sure. And yeah, and also if the key doesn't exist, then we return -1. Okay, so those are very good assumptions we have, so we don't have any edge cases at this moment. Yeah, so let's think about the solution. So the solution is to have the hash map to store. So first of all, we will define a double linked list. So the double linked list, the tail of the linked list is the least recently used key value. And for the hash map, we are going to store the key to the corresponding node. So for the implementation of the get API, we try to get the corresponding node based on the key from the hash map, and then update the double linked list. For the put, same thing. We are going to put the key and value into the hash map, and also update the double linked list. So both are going to be O1 regarding the time complexity for the get and put operation. So having said that, let's do some coding. So for coding part, first of all we need to define some members. So let's say this is the capacity, and we also need to have the hash map, which is the integer to node. This is, let's just call it map. So we are going to define a class, let's call it node, and it has several different members. The first one is the key, of course, and the second one is the value, and it also has the reference to the previous node, and it also has the reference to the next node. And then we have the public node. We have the constructor here. Let's say key and value. This dot key is equal to key. This dot value is equal to value. All right, so that's it for the node definition. And we are also going to have the head of the linked list here. So in the constructor, we are going to initialize the hash map. We are going to have the capacity is equal to capacity, okay, and node is equal to the new head should be a non-pointer. So for the get and the set, for the get key, I would say first of all check if the hash map contains the corresponding thing. So if map not contains a key, then simply we are just going to return -1. Otherwise, it means we have the corresponding node in the hash map. So that's the time we are going to say, okay, node.node is equal to map.get the key, and what we should do is we should first of all detach the node from the linked list. Then we are going to reattach it to the head of the linked list. Then we are going to return the node.value. Okay. So that is get. And for the put, same thing. So if map.contains the key, so if it already contains a key, then it means we are going to just do some update for it. So if it contains a key, we are going to say, okay, node is equal to map.get the key. Alright, so node.value is equal to updated to the value, and then we are going to detach the node and reattach the node, and then we just return it. Otherwise, it means that we have already otherwise it means that we don't already have the corresponding key and value in the hash map. So we are going to have the new node. So new node is equal to new node as the key and value. So we are going to put it into the hash map dot put as a key and what is that? This should be the node, okay? And we should also attach the node. So the thing currently is, we also need to check if the size of the map is larger than capacity. If map.size is larger than the capacity, then that's the time we are going to do something to remove one node. So we are going to detach the head.prev, which is a tail node, the least recently used node, and we are going to say so maybe let's say node remove node is equal to head.prev. So we are going to do that, and then dot remove the remove node.key. Yeah, so that's it. So we detach and then attach. So first of all, we attach the node to the head, and then we detach the last one. I think it should be okay. So the next thing for us to do is to implement some helper function. So okay, the detach and attach. So private void detach and the private void attach. Yep. So this is the node and node. This is a node and node. Okay. Yeah. So if I attach it, then it means we need to put it as a head node. So if head is equal to some non-pointer, then you're going to say head node.next is equal to node and node. So it's like self-reference is equal to node. It's like a single node circle. So we are going to say, alright, head is equal to node now, and we just return. Otherwise, it means it's not, the head is not equal to none, so we are going to say head dot next is equal to head, and node dot prev is equal to head dot prev, and no head dot prev dot next is equal to node, and head dot prev is equal to node as well. So we are going to set head as equal to node. Alright, so this attach, and then the next thing is about detach. How to detach the node from it. So so how to detach? So the thing is, if is it possible that we detach something? I don't think it's possible. If the head is equal to none, then we detach a something. So if okay, so if node dot next is equal to node. So if there is only one node within the double linked list, that means we just had set head as equal to the non-pointer. Otherwise, and then we just need to return. Otherwise, we will have node dot prev dot next is equal to node dot next, and node dot next dot prev is equal to node dot prev. So that's how to detach the node from the linked list. Yeah, so that's it. And also we need to say if node is equal to head, then you have node dot next head is equal to node dot next. Otherwise it's going to cause some problem. Yeah, so I think that should be it. So remember, the last thing is about testing. So usually we will go through some test cases manually to do sanity check, and at the same time explain how this piece of code is gonna work. But since we don't have enough time for this, I would just using my pure eye to explore the correctness of the code. So let's see. So first of all, we are going to initialize the hash map. So this is a cap capacity, and then head is equal to none. So when we try to detach it, if it is just a single node circle, then we are just going to set head is equal to none, then return it. Otherwise, if it is equal to a head, then head is equal to node dot next. Yep. And no, we are going to set node dot prev dot next is equal to node next, node dot next dot prev is equal to node dot prev. Okay. So that's how to detach a node from the linked list, and see how to attach it to the head. So if head is none, then you get a self-redirecting node and then set head is equal to node, then return. So otherwise, we are going to have node.next is head, node.previous, head.prev, node.prev.next is equal to node, head.prev, head.prev is equal to node. Okay, looks fair. So we have the get and the put. So when we get, first of all, we see if it contains. If not contain, we return -1. Otherwise, we get the node from it, detach it, and attach to the head. Then we return node dot value. Sounds fair. So for the put, we will see if it contains. If it contains, then we just get the corresponding thing updated, and then detach and attach, and then return. Otherwise, we are going to have a new node, and we are going to attach it, and then we are going to put it. If the size is larger than the capacity, then we have to find the tail node and then detach it and then remove from the map. Alright, all sounds fair. Let's give it a shot. Okay, it's accepted. It's accepted. Yeah, so you can see this is my second version of my implementation. Yeah, so for my first version, I actually made a stupid mistake, and I spent quite some time to debug where the code is, where the bug is. So I'll tell you where my previous bug was. So it was here. So I didn't set the node. I in the detach function, if node is equal to head, I didn't reset the head. So if I don't reset the head, then it is going to cause some serious problem, because the attach means we are trying to attach the node to be the previous head, and then yeah, and it caused a series of the issues. But glad I caught that bug, and then I redo this video. So that's it for this coding question. If you have any question about this coding puzzle, please leave some comments. If you find this video a bit helpful, please give me a like, and I'll see you next time. Thanks for watching.